Hi, today I want to make a short video about how you can add a buzzer to your IoT project in the Tinkercad Simulation software. So first, we need to bring out the buzzer component from the library sections. Just search the name buzzer, shows up here. So this sensor is called piezo buzzer. The purpose of this sensor is to make sounds depends on how you code it. So for on here, I need to spin the buzzer in different directions for easier connects. So how you spin the buzzer, you can click the button on the toolbar here, and you can rotate the buzzer in any directions you want. And now I'm connecting this to the breadboard. And first, we need to connect the positive side to the Arduino's digital pins here. Okay. Here I'm connecting it to digital pin 11, as you guys can see. And let me give these cables different colors. So let's say like brown colors. The negative side, we can connect it directly to the ground pin without any resistors. So how this buzzer works is similar to the LED, which is either it makes sounds or it doesn't make sounds, which is turn on and turn off, or like 1 and 0. So first we need to define the digital pins for the buzzer. So here this is how we define the pins for all the other sensors. Now we define a new one for the buzzer. We give it a name buzzer, and it is equals to digital pin 11 on the Arduino. That's why I put 11 here. Inside the word setup, we also need to put the pin mode defined as output for the buzzer. So just type pin mode the colon and put the name for the buzzer as we define at the here. Just type in the buzzer as output. The output here we need to put all capital letter. If no, it won't works. It will shows up errors. Okay, so on the loop sections here, this is how we define how the buzzer will make sounds in which conditions. So here I already have the if else statement put here. So let's say if my soil sensor value is below 300, I will make the buzzer to make a sound on. So first we need to type this code first, tone, and then the name for the buzzer as we define. And then the second column is how the frequency sound the buzzer will make. So here let's say I put like 1000. And the third column is how long duration the buzzer will make. So 1000 milliseconds, which is equals to 1 second. Then I can just copy the entire things, go to the next if else statements, next line, and here I can just paste here, put a different tone, let's say 800 hertz for the if the source value is above 300 but below 600. And the else here means it is above 600 or more. So let's say, and we do the same copy and paste and make a different tone, let's say 500. And this is how the code is. And now we run the simulation. So the soil level is now below 300, which is 0. Now it's making 1000 plus frequency tone of the masses. But if I adjust it above 300 but below 600, let's say like 300 things, it will make a different tones, which is the 800 hertz tone, as I define here. If I put like 600 above, let's say like 800 something, it will make a 500 hertz tone. Also, as I define in the code here. So this is how you do the code for the buzzer and how to do the connect the buzzer. And one more thing is that if you, let's say if you don't want a certain line of code to run, you just need to temporarily to log in. You can do like this. You can go to the code section that you want to temporarily disable and put 2/. Then this line of code will be temporarily disabled and it won't be executed during when you run the code. And let's start the simulation again. So since I already disabled the red LEDs, so if I put below 300, the red LED won't be turning on, but the other line of code will still work. Put it above 300. As you can see, the other conditions will still work, like the green LED will light up. It will still work. 600 and 300 between, and the yellow LED will still work. Only the red LED not working now. So if you want to make the code to works normal again, just remove the 2/ and the red LED should work as normal, as you can see here. So why is the buzzer here making the sounds with a bit of stop delays, as we can hear it now? It's because they put a short delay at the end of the code here, which is delay 1000. So every time you look back, it will delay like 1 second before executing the next code. So what if we disable this delay and see what will happen? As you can see, the buzzer sounds making more faster. So that's why we put a delay here to slow down the buzzer. This is how it works, and yeah, I think that's